This is a few examples of applications of systems of equations. Example 1, a theater with 200 tickets sold out on opening night, bringing in a revenue of $5,500. If adult tickets cost $30 and child tickets cost $20, how many of each ticket type were sold? So in this situation, there are two types of information. There's information that has to do with money, and then there's information that has to do with number of tickets. So from this information, we're going to be able to write a two-equation system where one of the equations has to do with the amount of money and one has to do with the number of tickets. So our variables are the things that we're solving for. How many of each types of tickets were sold? So we could call our variables X and Y, or we could call our variables A for the number of adult tickets and C for the number of child tickets. But if you prefer X and Y, that's fine. So from this information, the total number of tickets is 200. So however many adult tickets plus however many child tickets would add together to equal 200. So that's one of our equations, is A plus C equals 200. Now for the other equation, we know that each adult ticket is $30, each child ticket is $20. So we would multiply $30 by the number of adult tickets, A, and add to that $20 times the number of child tickets, C, and set that equal to the total amount of revenue, which was $5,500. Now we have a system of two equations to solve. We could use either substitution and solve for one of the variables in the second equation, or we could use elimination. I'll show elimination and we'll line up the C's. So with elimination, that means we need same variable, same number in front with different signs. So we would look for 20C and negative 20C. That means we need to multiply the second equation by negative 20. That would give negative 20A minus 20C equals negative 4,000. And then we'll just rewrite the top equation. 30A plus 20C equals 5,500. Then at the elimination step, we add the two equations together. 30A minus 20A is 10A. 20C minus 20C cancels. And 5,500 minus 4,000 is 1,500. So then we have the equation 10A equals 1,500. To solve, we divide by 10, and we get that A is equal to 150. So that's the number of adult tickets, is 150. Now we know that the total number of tickets is 200, so the adult tickets plus the child tickets would equal 200. Since we now know we sold 150 adult tickets, 150 plus the number of child tickets is equal to 200. To solve, subtract 150 from each side. And we get C equals 50. So this means that 150 adult tickets and 50 child tickets were sold. Example 2, two stores sell item X and item Y. The revenue for sales of these two items in these stores is given below. Find the price of each item. And for this situation, we assume that the price of item X is the same in both stores. The price of item Y is the same in both stores. So store 1 has the equation 10x plus 12y equals 2940. Store 2, 15x plus 22y equals 4890. So we could solve this by substitution, but let's solve it by elimination. It seems easiest to line up the x's because we could get 30x and negative 30x. So let's multiply the top equation by 3. That would be 30x plus 36y equals 8820. And then the second equation, to get negative 30, we multiply by negative 2. That equation then would be negative 30x minus 44y equals negative 9780. And then at the elimination step, we add the two equations together. The x's are eliminated. 36y minus 44y is negative 8y. Negative 960. And then we solve for y, so divide by negative 8. And we get y equals 120. And now we substitute back in to solve for x. So we could substitute into either the store 1 or store 2's equation. Either one would work. Let's substitute into store 1's equation. That would be 10x plus 12 times 120 equals 2940. Which would be 10x plus 1440 equals 2940. Solve for x. We get 10x equals $15, and then divide by 10 to get that x is equal to 150. So the price of item X is $1.50, and the price of item Y is $1.20.